Trigonometric ratios. We know the definition of trigonometric ratios from our work on right-angled triangle trigonometry. So if I have a right-angled triangle and I'm considering this angle here, which I'll call theta, this side is the hypotenuse, this is the adjacent, and this one is the opposite. The sine of the angle theta is defined to be the length of the opposite divided by the length of the hypotenuse. The cosine of the angle theta is the length of the adjacent divided by the length of the hypotenuse. And the tangent of the angle theta is defined as the length of the opposite divided by the length of the adjacent. Because we have worked in a right-angled triangle, our angles all have to be in the range between 0 degrees and 90 degrees. Remember, the three angles add up to 180 and this one's already 90. So the angle theta here can only go between 0 and 90. Now that we are using the unit circle, we can extend the range over which we can define the ratios sine, cos and tan. And I can't stress how important this is in mathematics. So what we're going to do is look at each of the four quadrants. This is going to take a while. It's not that straightforward and it's very important to understand. So please take time on this. So the first quadrant is from 0 degrees, which we've already discussed in a previous video, is here, around to 90 degrees, or if we're in radians, that's 0 radians to pi by 2 radians. And it's really important that you start to get a handle on these things in radians. So this is the quadrant we're working in, and we'll see later that it's known as the A quadrant. Let's just take some general point here, and let's say that point has coordinates A, B. So if I form this triangle here, this length is A, this length is B, and we know that it's a unit circle, so the hypotenuse is 1. Because of where we are on the graph, we know that A and B are both positive numbers. We've got a positive x coordinate and a positive y coordinate. So the sine of this angle here, which I'll call theta, would be equal to the opposite, which is B, over 1. The cosine of theta would be the adjacent, which is A, divided by the hypotenuse, which is 1. And the tangent of theta would be the opposite, which is B, divided by the adjacent, which is A. And because we know that A and B are positive, that means that the sine is positive, the cosine would be positive, and the tangent would be positive. So all three of the trigonometric ratios are positive, and that's why we call this the A quadrant. They are all positive. So we're now going to look at the second quadrant here, which is between 90 degrees and 180 degrees. If we're in radians, that's between pi by 2 and pi. So we're going to consider an angle now. That's this angle. So it's an obtuse angle that we have. And we're going to have a point here with coordinates A, B. And what should be clear from where we are on the graph is that A is negative and B is positive. Now we only know how to define the trigonometric ratios in right-angled triangles. In other words, for angles that are between 0 and 90 degrees. And the angle theta here is obtuse. So what do we do? Well, the way it's defined is that we form a right-angled triangle just here. And we say that this angle alpha is the associated angle with the theta. As we work around the diagram, we'll see that when we do this, the angle is always the angle between the line where we are and the x-axis. So it's always the angle to the x-axis. And what we say is that the sine of theta is equal to the sine of alpha. But here, that's the opposite, which we know is B. So this is 1 and this is A. So that's going to be B over 1. And B is positive. So the sine is positive. But if we define cos theta to be equal to cos alpha, in this situation, that's A over 1 with the A being negative. So the cosine is negative. And then the tangent of theta is the tangent of alpha, which is B over A. B is positive, A is negative, so that also is negative. So between 90 and 180, the sine is positive and the cosine and tangent are negative. And we call this one the S quadrant for that, because only the sine is positive. So now we're going to look at the third quadrant. So we'll take a point here with coordinates A and B and look at where it is on the graph. We can see there that they are both negative. So A is less than 0 and B is less than 0. They're both negative. And the angle we're actually looking at is this angle here, theta. So it's between 180 degrees and 270 degrees. And in radians, that's pi, and 3 pi by 2. And we form the right angle triangle here. Remember, I said the associated angle would always be to the x-axis. So I'm going to call this angle beta. It's a unit circle. And we know that this is B and this is A. So we'll define the sine of theta to be equal to the sine of beta. And that's going to be B over 1. And B is negative this time, so the sine is negative. The cosine of theta is the cosine of beta, which is A over 1. And that also is negative. And the tan of theta is going to be the tan of beta, which is B over A, opposite over adjacent. And B and A are both negative. Negative divided by negative gives us a positive. And that's why we call this the T quadrant, because the tan only is positive. So finally the fourth quadrant, and we should know what's happening by now. We're going to take a point here, P, A, B. We can see that the x-coordinate, so A is going to be positive and B is going to be negative. And we'll form a right-angled triangle so that this is A, this is B, this is 1. And we're going from 270 degrees around to 360 degrees, which means 3 pi by 2 radians around to 2 pi radians. The angle we're actually looking at here is this angle theta, but the associated angle we'll call gamma. And note once again, gamma is to the x-axis. So sine theta is defined to be sine gamma, and of course that's b over 1, and b is negative, so the sine is negative. Cos theta is going to be cos of gamma, which is a over 1, and of course that is positive. And tan theta would be tan gamma, which is b over a, and so we're doing a negative divided by a positive, which is negative, and so only the cosine is positive, and this is known as the C quadrant. So overall we arrive at the cast diagram ASTC. All of the trigonometric ratios are positive here, only the sine here, only the tangent here, and only the cosine here. And it's really, really important, this unit circle. You need to remember it. There are some mnemonics, such as all stations to Cambridge. My personal favourite is all students take cannabis.